So, a priest, a member of a Nobel Prize winning team, India's former G20 Sherpa, and three of the most influential builders and scalers across India and Africa when it comes to AI walk into the ballroom at the Oberoi. This is either the beginning of a great joke or a great conversation, and I'm personally hoping it's a little bit of both. I'm Nidhi Singh from Carnegie, India, and I have the privilege of moderating tonight's discussion on AI for the world. Now we're at a summit about AI, so clearly there's been a lot of conversations about models and compute and capacities, and those do matter. But I want to start this session by talking about something a little different, and that is that AI's central challenge is no longer invention, it's diffusion. So the question isn't can we build powerful AI? We can. The question is who benefits when we build this AI? Because right now the gap between what AI can do in a lab or in a demo and what it does at population scale in resource constrained environments is enormous. The infrastructure is uneven, the talent gets pulled towards a handful of countries and companies, the governance conversations are still happening relatively in the global north, and they're shaped by a relatively small set of stakeholders. So the most promising interventions that we hear about are stuck somewhere between pilot and unable to scale. At the same time, we have some people here on the stage with us that are proving that it doesn't have to be that way. And we're going to get into what it actually takes to make AI work for the world. So, the idea here is that I want to quickly go through a set of questions for everybody on the stage. This is just the beginning of the conversation. And then we'll let the audience come in with some questions as well. So we'll start with the scalers and the builders. We'll move on to Mr. Khan, and then we'll save the easiest questions, which are questions of faith and science. So I'll start with you, Ernest. Sunbird has launched Sunflower, which is a multilingual model, and it outperforms most major models when it comes to the Ugandan language. What makes this so different is that you've actually built this using locally sourced data rather than the internet scale data sets which are in vogue right now. So, honest, what does this tell us about the assumptions that people have around what it takes to build an AI that actually works for the people?
Thank you very much, and thank you to ORIF for inviting me. I'm called Ernest. I've been in the journey for trying to make AI and machine learning work for Africa for quite a while. I think since 2012, when AI was not cool. There was a time when AI was not cool, and explaining what AI was quite difficult. Sunbird AI is a social enterprise that tries to do AI for social good, but we try to do it in a very practical way. So practical means that we try to deploy and try to get people to use the technology. And this means several things. So back in 2012, 2014, we used to work with farmers. And what we're building back in the day with very limited tech was an app that could take an image of a plant, a crop, and provide the diagnosis. And this was cassava. And the very first time we did it in the lab and it was working, it looked good. We took it to the farmers, and one farmer, a gentleman, got the app and took an image of his wife. And the result was a disease in cassava, cassava mosaic. And the guy said, "No, this doesn't work. This just doesn't work." And we kept thinking, "Wow, that was not a thing we thought about, right?" So I think the very first assumption is we do pilots and assume this will automatically scale, and yet the context is quite complicated to get right. So when we build the Sunflower models, the early versions of building language tech 5 years ago, again, we thought it would work automatically. We tested it, and we gave it to people, and the very first word they type is hello. Translate hello in my local language. And it got it wrong. It got it wrong every time, because there are very many ways people say hello. And so I think context has been a really big thing to make things work. And what we did with context is, one, community. Go to the community, refine these models, have people test these models, and have people break the models. I think we had this session called Break the System, where we asked people to actively break the system, break the models. And this was very helpful in sort of making sure we build a system that works. I think that was one. The second was conviction, which is not something we've had here a lot. So I don't know how to define conviction, but there's you can think of work people do for 8 to 5. So if you're doing the thing 8 to 5, and the people who are convicted enough to do it the extra mile to go past 5, and there's a way, and that's very important. This work is very hard to get right for people to use, and I think to have the right conviction to people, the right talent that has the right conviction, I think is very important. I'll stop there. Thank you.
Thanks, Ernest. I just want to talk a little bit more about something that you've mentioned, and I think that'll link to something that Chico's doing as well. You've talked about how there's an assumption that pilots will scale and what it takes to make something work. So, Chico, you've built technology interventions across health and employment, agriculture, payments in Africa for a long time. Some have scaled, some have not. Very simply, with all of that experience, what is the most reliable signal that you've seen so far that something is going to scale?
Thank you so much. Thank you for having me. And I'm really privileged to be in this room. And the one signal is something I think Prime Minister Sunak said. It's about, are we solving a problem? Yeah. Sometimes we build for our own feel good feeling. Yeah. We're saying, and today we've had it from the very morning is we want to solve AI that is for impact, lifting the floor, not being selfish. I love what the uncle from Gates said. It's about models that will leave an impact. What does impact mean? And I love that you use the word conviction. It is about being able to solve something for the other person. And sometimes that hurts for you as a builder. And I'm coming from a computer science background where we love building stuff, right? But if somebody cannot use it on their daily use, it's not solving an actual human problem. And then at scale, then you know there's no way of saying that this you're solving a problem, right? And that is how you do it. So, for example, you talked about the farmer, and I'll give an example because I really want you to go to the AI village and see this one. There's a group of doctors who came to us and said, we are building all this nice model of like telling cancer prediction, talking about science in AI. But you know what? We're not solving the actual problem. When a mother is sick or is about to give birth in a rural farm in Kenya, what do? They call their motorcycle driver to take them to hospital. Most of the time, 40% of the time, the baby or the mother will die before they get to the medical space. What can AI do for that woman? And for us was like, we don't know. And said, yes, solve for how the woman gets to the hospital. And so they built this, honestly, it's a very simple language, small language model that takes information from the medical directory, converts it into very, very simple language that anybody with this app can be able to provide fast aid healthcare, can be able to provide a woman with like fast response to be able to give birth, or to even take care of something like what is it called, the high blood pressure when a woman is giving birth. And that's what AI should be. It should apply to things that are not solving for yourself. Because when I'm saying I have a cancer model, it looks good on me and on my papers, but doesn't look good on the woman that is giving birth on the way to hospital. Thank you.
Thanks, Chico. I think that's a really good point around what successful AI looks like and how do we really measure the success of AI. Um, so I think one of the things that I want to now bring around to you, Shalini, is that you've also talked about different models for AI success. And one of the things that you've talked about is how you have a lot of pilots that are coming up. But the success of AI isn't dependent on how many pilots you have, but on how many actually scale. So, how many work and how many can sort of be increased to something that works in a resource constrained environment and it can still scale for the population. So, can you tell us how much of India's AI ambition currently is stuck in what you've called this pilot purgatory? And what does that really mean?
Yeah. So what we did was we studied almost 500 use cases across entire global south to understand uh, the pilots across agriculture, healthcare, education, and 70 to 80% were still stuck at pilot level. They were struggling to go at production grade. And what does production grade mean? And we figured out that they are either struggling for data, the right data, localized data. It works somewhere in some region, it doesn't work in other region because everything has to be retrained, recreated, and that needs more compute, which maybe they don't have. It's struggling for multilinguality because something created in one region and it has to have multiple languages, so language capability into it. The third was accessibility in various forms rather than just like a smartphone, the voice AI, because people want to interact and talk in their language, in their mechanisms, or what they have been used to on, say, on feature phones where there's no internet connectivity. There was also a need of, and why pilots they remained at just at pilots and not at the population scale, is also because the safety benchmarks were not created based on what the localization need was, which means that today the safety benchmarks are driven, say, by the compute great models, but it is not in terms of, say, conversations, multi-turn conversations. Every model will be very good if you just give one question, but you continue and asking and do three different turns, so multi-turn conversation, and that too in a context of agri or in a context of healthcare. There is no benchmark, and there's a lot of work to be done in that space. So we said, okay, let's what we should do is we should spend our time in building these pathways and pathways for data in agri, data in health. And that's what we launched today. In fact, Nandan Elikeni, just before this session started at 3:30, he announced 100 pathways to 2030. Because once we have the pathways, thousands of use cases will happen. Thousands of use cases will lead to a population scale. I'll give one more example, which is of data. The data linkage and data silo problem we all have seen. We recently worked with Ministry of Statistics, the MOSPI, and we said, okay, 10 data sets. They are the ones, by the way, who create the GDP, and they have data from the source at district level, taluka level. So they know the consumer price index, they know the wholesale price index. Now that information is now, that data sets is now AI ready, which means it has a model context server in front of it so that it's accessible by LLMs, by agents to build more. So a new data economy can start. So a new linkage can happen between sectors, and that opens up right from the foundation. It starts opening up. So these kind of innovations and these kind of pathways have to be created in data, in benchmarks, and that will power the real use case. One last use case which I want to talk about is Amul. I'm sure each one of you would have seen how Amul happens today because of Amul AI, which is Sarla Ben, uh, a milk farmer. She has a choice. She has a choice to use feature phone because maybe her husband has the smartphone and has not given her. She can use a feature phone to talk in her language in Gujarati over a feature phone and find out why the cow has given less milk and what is the nutritional plan. She can converse in that so that she can give it to the cow and bring back the money in her pocket, which has gone down because maybe a cow was sick. So when AI brings money in the pocket of the people, then people will start adopting it. And that's the AI diffusion into society, which once taken care of through these 100 pathways will lead to population scale AI. And that's what is India's game actually.
Thanks, Shalini. I think from the comments that all three of you have made, we can see that there is, and this has been the theme for conversations for a while now, there's some need for collaboration to figure out how do you scale AI solutions. Clearly, there are a lot of really promising AI solutions that are built around impact, built with humans in the center. But how do you sort of scale that up, make that bigger, ensure that even in resource constrained environments, even with the feature phone, people can have access to this? So, as we talk about this, I am going to turn to you, Mr. Kant, as we talk about scaling and how to bring something to population scale. So, India's DPI story, Aadhaar, UPI, India Stack, is one of the most referenced models when it comes to bringing things to population scale. But this was built on relatively mature technology. can this open interoperable playbook that we had for DPI really work for AI when it evolves a lot faster, when there's not as much collaboration between the people who are building it, and it's not really that well understood even by the builders of AI?
So thanks for that question. And so my view is that first and foremost that AI which is not multilingual, which is not low bandwidth, and which is not based on voice, uh, will not lead to digital equity and will create great inequity in society. And the learning experience from India's digital public infrastructure is that we created an open source model, which is open API and is globally interoperable, because we created a digital public interest layer. And on top of that, we allowed private sector to innovate and compete. So India is the only country where Phone Pay competes with Google Pay, Paytm competes with Amazon Pay on top of the digital public interest layer. What you need to do is to do a DPI for artificial intelligence. That's important, because which would mean that you need three things. You need data, you need talent, and you need computing power. What the India AI mission is doing is it's saying that we will open up the government data sources through AI Kosh for all the researchers and startups. We will provide you computing power through at subsidized rate, much cheaper than the western part of the world. And we will support 10 large language models to be built up in India. And that is the approach that is driving so that we can build an affordable and accessible and an accountable model which is multilingual in nature. And that is what Sarvam has done, which was launched today morning. So what this demonstrates is India's commitment that in the long run, technology actually leads to a lot of inequity in society. You're pumping in so much of resources, so much of computing power. What India's attempt is that you should be able to optimize it, you should be able to do sophisticated software with limited computing power, but ensure that this DPI for AI is able to transform lives of citizens, that you are able to improve learning outcomes, you are able to improve health outcomes, you are able to improve nutritional standards, you are able to remove and eliminate stunting and wasting. Anything which is not multilingual, which is not low bandwidth, which is not voice-based, AI is not fit for purpose for today's society. And to my mind, will lead to greater digital inequality in society. And therefore, the model for India is based on this. And once we transform the lives of the 1.4 billion people of India, we'll actually be transforming the lives of the next 4 billion people who will be moving from poverty to middle class in the global south.
Thank you, sir. The framing of fit for purpose models, I think, is a really interesting one, and it's a very important one, because we're not going to all be building the same AI models. We aren't all competing in the AGI race, and I think that's a very interesting framing to provide, that you need to build a model that works for the people and it's fit for purpose. We're going to break up the order a little. Pushmeet, I'm going to come to you first. So you were part of the team that's built AlphaFold. AlphaFold has basically taken what is multi-year, multi-million dollar processes, and now you can have something that can take seconds instead. And then you've sort of made these results openly available, and it is essentially a scientific miracle to be able to do this. But building it has required the entire resources of Google DeepMind. So, what do you think about this tension that exists, that you can have answers that now come in seconds instead of taking this much time and resources, but it did in fact take that much time and resources?
Yeah, I think there's a interesting sort of point to be made there, is that the technology requires big investment, and not just investment in capital. It requires investment in various different other resources. It requires investment of thought, of multidisciplinarity. It was not something that was, it was not a breakthrough that was just achieved by machine learning people working alone. It was a breakthrough which came about because machine learning researchers, engineers were working with biologists together to sort of overcome this grand challenge which has been standing for the last sort of 50 years. And why did we choose that specific problem? It was because it was a root node problem that eventually had impact across a huge spectrum of different domains. When you think about a model like AlphaFold, what it does, it allows you to really shed a light on the inner workings of biology. When you think about biology, you think, well, maybe it has some implications for drug discovery, and that's where the commercial impact comes from. But that's just scratching the surface. There are 3.3 million researchers which have used AlphaFold across the world. If you had told me that there are 3.3 million people who will be interested in AlphaFold, I would have not believed you. I mean, the fact that 3.3 million researchers around the world are using this specialized protein structure prediction model, it just tells you how far humanity has come. What is even more surprising is that 1/3 of them are in low and middle income countries. So that researcher who was working on Chagas, some tropical disease, a neglected tropical disease, who had no way to find the structure of this protein to tackle this problem, now can do it at the click of a button. What staking millions of dollars, multiple years, a synchrotron to get the 3D structure can now be just downloaded from the internet for free. So that is amazing. There are 180,000 researchers in India who are using AlphaFold. And they're not just using it for drug discovery. They are actually developing new crops that are resistant to fungus. They're doing it for food security. They're doing it for decomposing sort of plastics and treating pollution. So you can look at the scale of what one single breakthrough can enable. Now the key question was the investment that was put in, and many people have asked me, you put in this investment, you did sort of 5 years of research, brought this multidisciplinary team together, and then you made it available for free. How do you make sense of it? And I think that it's very easy to sort of make sense of it, because like if I think the minister earlier was making this analogy of oil, and you shouldn't be selfish. It's the same way. If you're building this technology and that technology isn't used for the impact, then it will not have impact. So you really, AlphaFold's impact on drug discovery, on dealing with plastic pollution, on sort of understanding biology came about because it was made available. And then we followed it up with specialized sort of companies like Isomorphic, which are specializing into sort of drug discovery. So yes, there is a lot of investment into AI, and which is required to achieve these major breakthroughs. But at the end of the day, the main sort of focus will be on impact. If you don't get impact, then it's just a technology. It's just a toy. It's only when it is in the hands of people who are using it to solve important problems that the world is facing that it will translate into the real sort of benefit. Now, Mr. Kant actually rightly said, right, that you have to make this technology accessible so that it's accessible to the world. And I feel that there are two elements. When we talk about AI, we think about it as a monolithic thing, that is just one set of competencies. It's not. It's multiple things. It's a thing which democratizes expertise. It's basically democratizes high quality education, high quality healthcare. And for that, it needs to be accessible to those 1.4 sort of billion Indians and the 8 billion people on the planet. But at the other end of the spectrum, it's also about going beyond humanity's knowledge in terms of really figuring out what do we know about the world? How do we deal with new challenges in biology like future pandemics? How do we deal with sort of grand challenges of energy security? How do we deal with great challenges of dealing with climate change? And that's where the true promise of AI lies in the future.
Thank you, Pushmeet. I think for the last question, I want to take us to a much higher view of this. We'll go back up to a 10,000 feet view of what the challenges are. Father Benanti, I'll come to you now. So, you've worked on the Rome Call for Ethics. In a world where there are almost as many ethics documents as there are AI pilots, that one stands apart because it became the first document that was signed by leaders of the three faiths alongside major tech companies. So, in a world where values differ quite greatly, and they differ enormously across different cultures, is this sort of a minimalist ethical framework enough to actually change the behavior of people?
First of all, thank you for having me. I'm so happy to be here. Well, let me start where it stops. We had the same confrontation last year, so it's like an ongoing journey. 1 year, exactly 12 months ago. Well, we have a problem. And the problem is this. From 60,000 years ago, when for the first time our species take in his hand a clapstick, was it a tool or a weapon? Was it something to open much more coconut and give food to people and democratizing food? Or was a good weapon to open much more skull of people and being less democratic? So there is no way in which all the dream and desire that we heard can be given for granted to hit the target of innovation that means progress. And this is where ethics come in the stage. So we need some kind of guardrail, that guide you to the goal that you desire. But when we talk about ethics, let me do a really Italian example. Sorry for that. It's like when on Monday you are discussing on the soccer football match of Sunday. Everyone know how the match has to be gone, but no one played it. So everyone is ready to judge someone else's decision, not ready to play in it. And here we have a problem. And the core element is this. We are a lot, we are different, we have different sensibility. There is a set of values that are workable. Well, to make short a long discussion, no. But this is not an ethical problem. Why? Let me make once again on myself an example. Let me tell you a secret. I'm a Catholic. That's the secret. Well, thank you. Well, for Catholic, marriage is really important. But myself, I'm not married. So neither a really deep Catholic value is valid for every Catholic. So we have not to focus on value. What else we can have? Well, let's say something like, for example, norms. But a norms is something that is made to protect a value. If life is a value, do not kill is. So also norms are not workable. Should we declare ourselves defeated? Should we renounce to the dream that we hear today? Not at all. There is another element in ethics really important. There are principles. So supposing that there is a fully autonomous car, and this fully autonomous car found itself in the unavoidable condition of having an accident. You don't know who you are in that scene. The driver, one man on the street, someone else. Make it sense that the machine try to minimize the damage? Welcome to ethics. So ethics is a negotiation principle, and what we heard here are simple principles of use of things that are already inside us. So there is no need for an outside download of that, but we need dialogue. We need to dialogue among us to allow such kind of workable principle to be the guardrail to transform innovation in something that we can define as development and really progress for everyone. So my job is easy. I make the question, I don't give any answer.
Thank you, sir. I am cognizant that we only have 1 minute on the clock. So we will take one question from among the audience because I do want somebody to have a chance to interact with the audience. Do we have a question? Yes, over there.
I have actually a question for Mr. Benanti.
because I know that you would like to leave questions, but I would like also one answer, please. Actually, what are the principles that you believe that AI should never breach? What are the values that, like, how do you even define values? How do you define principles? So, how can we regulate or see how AI works if we don't know what is the limit?
Thank you for the question. I'll try to be super fast. Well, there is not a universal set of principles because there is not theoretical good. If you have a thirsty man, one good thing is to give him something to drink. So the principle is go in the face of his need. So because there is not a universal condition, you have to focus on the subject you are working on. On AI, well, the first thing is, for example, this idea that AI is a wonderful machine to find pattern in data and maximizing things, it's good. So let's discuss in this condition, in this kind of situation, what is the goal of what we would like to maximize. Then let's use AI to bridge us to that. And you can maximize, for example, the income of seed seller to people, and it's not good. Or we can maximize the amount of agricultural people to get from their own field. Well, AI is good in finding the maximum or the minimum. Not all are workable. There is no way to make ethics without discussing among humans. Short answer.
Thank you so much, sir. And thank you to all of my wonderful panelists. It's been really exciting to hear about how everybody's building AI for the world and how we all have such different but more or less the same challenges, actually. Thank you.